Hi, I'm Dimitris Charalambidis, and in this presentation we learn how to understand dependent linear systems algebraically. As we know, a system of linear equations is called dependent if it has infinitely many solutions. In this presentation, we will see how we can know from the beginning when a system is dependent without even solving it. At first, we must understand that when we solve a system of linear equations, we actually try to find if there are any points of intersection between the system's lines. These points of intersection are the system's solutions. If a system is dependent, as we said, this means that it has infinitely many solutions. Thus, the system's lines will have infinitely many common points. And this can only happen if the system's lines are the one on top of the other, or, in other words, if all equations in the system describe the same line. But how can we show that two equations describe the same line? We already know that the form y equals mx plus b is called slope-intercept form of a line, and that's because m is the line's slope, while b is the line's y-intercept. These two values are unique for each line. Hence, given a system of linear equations, we can take each equation and try to bring it, if it's not already, in this slope-intercept form. Now, if all the lines have the same slope and y-intercept, then all these lines are the same. And that will mean for our system that it will be dependent. Let's see an example to understand it even better. State, without solving it, whether the system x plus y equals 2 and 2x plus 2y equals 4 is dependent. As we said previously, we will take each equation and write it in slope-intercept form. This can be done by solving for y. So we take the first equation, the equation x plus y equals 2, and solve it for y. Thus we get y equals negative x plus 2. This means that this equation, which represents a line anyway, has a slope of negative 1 and a y-intercept of 2. We do the same for the second equation. 2x plus 2y equals 4, thus 2y equals minus 2x plus 4, thus y equals negative 2x over 2 plus 4 over 2, thus y equals negative x plus 2. Again, the second line also has slope equal to negative 1 and a y-intercept of 2. This means that both lines have the same slope and the same y-intercept. Thus, they are actually the same line, as we can clearly see in front of us. This means that they have infinitely many common points, and that, for our system, means that it has infinitely many solutions. Therefore, it is what we call a dependent system. For any questions about this presentation, you can leave comments down below, or you can contact me with one of the following ways. As always, thank you for your time.